Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16E2, refers to a PGM-FI-ACG LIN communication error specifically related to the Honda Accord models from 2023 and beyond. This code arises when the Powertrain Control Module, PCM, fails to properly receive signals from the alternator through the local interconnect network, LIN. The LIN is a low-speed communication network used in vehicles to connect various electronic components. In this scenario, the abnormality detected by the PCM results in the storage of the DTC. The alternator is a critical component that generates electricity for the vehicle's electrical systems, while the PCM coordinates these signals to ensure all systems function correctly. The detection of this error can lead to performance issues and should be addressed promptly. The DTC P16E2 indicates an issue concerning the Powertrain Control Module, PCM, and the alternator's ability to communicate properly. The PCM is responsible for managing engine operations and monitoring various components, including the alternator through the LIN system, which ensures accurate communication between components. The alternator is located in the engine bay and plays a vital role in generating electricity to power the vehicle's electrical systems. Any failure in communication between these components can lead to abnormal system behavior. A loose terminal at the alternator's +B terminal could also trigger this DTC, indicating that meticulous inspection of electrical connections is essential for troubleshooting. The potential causes for DTC P16E2 primarily include a loose terminal connection at the alternator's +B terminal. This situation can prevent reliable signal transmission between the alternator and the PCM. Additionally, issues within the LIN circuit, such as wiring faults or short circuits, may also lead to a breakdown in communication. A defective alternator itself can be a cause if it fails to send proper signals to the PCM. Lastly, problems with the PCM, like internal faults or software issues, could also trigger this DTC. Each of these possibilities necessitates careful investigation to isolate the root cause of the error. Symptoms associated with DTC P16E2 may vary, but typically include the illumination of the engine warning light on the dashboard, which serves as a primary indicator to the driver of underlying issues. Drivers may also experience charging system problems, such as insufficient battery voltage or failure to start the vehicle. Additionally, electrical malfunctions in various systems may arise due to the alternator's inability to generate adequate power. Performance drops, like decreased acceleration or responsiveness, may also be linked to this error code, making it crucial to address these symptoms to ensure vehicle reliability. The first troubleshooting step involves placing the vehicle into the on mode and allowing a wait time of 10 seconds. This action enables the PCM to initiate normal operations and helps reset any temporary issues that might have caused the DTC P16E2 to trigger. By starting the troubleshooting process in this manner, technicians can confirm whether the communication failure persists or if it was a momentary glitch. It's essential to follow this procedure accurately, as it lays the groundwork for further diagnostic efforts. If this step leads to the persistent storage of DTC P16E2, additional inspections must then proceed to determine the root of the problem. The next step focuses on inspecting the LIN circuit to ensure that there are no open circuits causing communication breakdowns. It's vital to check the wiring quality carefully, as any breaks or corrosion in the circuit can yield incorrect signals to the PCM. Technicians should utilize a multimeter to evaluate the resistance along the circuit. It should show less than 1 ohm in normal conditions. If any resistance values are found to be too high, further investigation into electrical continuity is warranted. This thorough analysis of the LIN circuit will help eliminate it as a potential failure point or highlight the need for repairs. The next troubleshooting step involves inspecting the alternator connection directly. This includes verifying that the connector is secure and that there are no visible signs of damage or corrosion. Given that the alternator is a crucial component in generating electricity, its functionality should also be assessed at this stage. Because there is no direct testing method for the alternator itself, checking surrounding components connected to it becomes imperative. Any anomalies observed during these inspections could be indicative of why the PCM is failing to receive proper signals. At this stage, further tests may be warranted if the alternator exhibits abnormal behavior. This step necessitates the meticulous inspection of the PCM connection as a significant part of troubleshooting DTC P16E2. The PCM should be checked for any loose terminals or faulty connections that contribute to poor signal transmission. If previous inspections indicated that the alternator and LIN circuit are functioning correctly, then the PCM itself may be the source of the communication failure. Evaluating the PCM's functionality and ensuring that it is in good working condition is essential in determining whether it has internal faults or communication failures. Only after confirming the integrity of the PCM can one rule it as a possible cause of the error. Once all necessary repairs and inspections have been completed, the final step is to perform a reset of the DTC codes. This process allows the vehicle's PCM to clear any stored faults relating to DTC P16E2 and prepare the vehicle for a normal state of operation. Following the reset, a test drive should be conducted to assess the overall functionality of the vehicle. During this process, it is crucial to monitor various systems to ensure that no further warnings appear and that the vehicle operates as intended. If successful, this final verification will confirm that the troubleshooting and repair steps were effective in resolving the initial communication error. Preventive maintenance is critical to avoiding the reoccurrence of DTC P16E2 and ensuring optimal vehicle performance. Regular checks of all electrical connections, particularly at the alternator and PCM, can prevent issues from arising. It is also essential to inspect the wiring harness for signs of wear, fraying, or damage, as these can jeopardize communication within the LIN circuit. Keeping the alternator clean and free from corrosion will ensure that it maintains proper connectivity. Proactive maintenance practices like these can significantly reduce the likelihood of encountering similar issues in the future, providing peace of mind and reliability on the road. In conclusion, DTC P16E2 highlights a significant communication error between the PCM and the alternator, indicating the need for careful inspections of connections and wiring. The systematic troubleshooting steps presented are essential for identifying the root cause of this issue and ensuring effective repairs. Properly addressing this DTC will facilitate improved performance and reliability for the Honda Accord Model 2023 and beyond. Moreover, preventive measures can play a pivotal role in maintaining optimal vehicle health and reducing the chances of future communication breakdowns. The knowledge and thorough understanding gained through this process ultimately contribute to the longevity and efficiency of the vehicle's function. Please like and subscribe to the channel. See you next time.